Hello all. Myself Dr. Bhumika Shah from Department of Computer Science, Gujarat University. It is indeed a pleasure and a privilege to be participating in this teaching challenge consecutively for the second year. I'll be discussing about table design today, table design in relational database management system. So design actually is a stepwise process. And in order to explain table design to the students, there are certain prerequisites for the table design, like we uh, explain the students with set theory concepts, then relational algebra, then we take them to data models, ER data model, and normalization, and actually achieve a proper database or rather a table design. So as mentioned that it being a stepwise process, here we first of all discuss set theory very briefly, though in class we take set theory into detail, then to relational algebra, and then move on to the designing part. But just acquainting with how the set theory concepts are taken forward, the students are explained about how they can relate the sets to real life objects. What are the elements of set actually known as? How the elements belong to the set? How are they? How the objects are introduced into the set definitions, and how the sets are denoted uppercase letters, elements, how are the elements denoted with the lowercase letters. Then we introduce them to relational algebra concepts. In relational algebra concepts, we explain the various operators like selection, projection, union, Cartesian product, set difference, rename operator, how the predicate selection helps you to eliminate tuples, how the predicate projection helps me to portray the attributes or help me to display the selected attributes, how can I use multiple relations with the help of union, because by default, all relational algebra operators will be taking two relations as input and will be giving the new relation as output. I also have the option of breaking the entire query into parts and projecting them as a new relation. All those concepts are explained into detail with reference to relational algebra. Once the students have understood the mathematical connection or the mathematical aspect of this design process, we actually move on to data models. We talk of different data models like the flat file models, traditional models, object-based models, semi-structured. And we actually show them the comparison between the flat file or hierarchical. Like say, for example, if I am saying that flat file stores everything at one place, whereas hierarchical will have a tree-like structure, whereas my network will have entities organized as graphs. But as soon as I'll come to relation, it will be entirely, everything will be in form of relational constructs. So we actually observe or we actually explain the relational data model then. Now here our core focus being relational and data model. We'll discuss more of ER and relational data model rather. The other models also are discussed very shortly with reference to how they are related actually to real life objects, that is object-oriented models and some of the semi-structured data models. But when I say I want to focus more on to relational data model, I actually am trying to explain how the relational data model is bounded through 12 chords rules, how each rows and columns or how the rows and columns are actually represented as tuples and attributes. So once we are going here to relational data model, we actually explain the class through this table-like data structure. We explain them how when you are representing something as rows and columns, what are the attributes here, what are the tuples here, what is the relation here, what are types of attributes, where have you used numbers, where have you used only characters, where have you used the combination of numbers and characters. So what actually we mean by a relational schema over here, the example customer is given for the customer schema. What do we actually mean by a relational instance? That is the value of a relation specified by a table, and then how the overall design is termed as a database schema. So this is how we introduce them to the relational data model. Of course, as mentioned, semi-structured models are there, object data models are there. But we would here rather directly move on to the entity relationship model. So with reference to entity relationship model, we explain the student what are entities, how you are relating your real life entities, what is a student, when would you say that this student is a real life object, how are you plotting that student as an entity, how are you plotting department as an entity, how are you plotting course as an entity, what is the role of entities in a relationship, what could be the constraints like if I say that a course can admit maximum 60 students, if a student has to be at least greater than a particular age to be enrolled in a particular course. So there are domain constraints, there are key constraints, there might be cardinality constraints, there might be constraints on the relationship. So we explain all of these things about the entity relationship model, and we actually show them the symbols which are used for entity relationship model. How are the entity sets denoted? How is the attribute represented? What is derived attribute? What do we mean by weak entity set? How the multi-valued attributes are denoted? How the primary key is denoted? What is the meaning of the dotted line? Discriminating attribute of a weak entity set. Once this is done, actually the students are shown some of the samples. That is, I discuss some of the ER diagrams into the class, draw certain ER diagrams as part of the exercise. Students are made aware that where we are using which type of symbols. And once they have understood the concepts entirely, we actually start this activity into class of introducing it with a model of gaming. So what do we do that we have a class of around 50 students and we divide them into 5 or 6 student group. Each group is given one case study. Like we introduce different case studies of university, of hotel, of restaurant, of online shopping, of hospital management, whatsoever. Different case studies were introduced. Each group was given a particular case study. Each group was given around 20-25 minutes time to perform or to draw diagrams into their notebooks. And then one participant from each group would come on the board and draw their class's diagram. So once the particular student of that group has drawn the diagram, we take a discussion in the class discussing about that diagram. All the students give their suggestions. So and so is missing, so and so is extra, what is not mentioned, etc., etc. Then the class faculty or the teacher gives his or her expert opinion, and the students note down the entire correct solution of the diagram. So this is one of the diagram. These are some of the pictures of the activity we did in class. Then the diagram which was drawn by one of the student. And as you observe in the diagram, this is the diagram which was drawn. And as you observe, the relationships are not plotted. Weak or strong entities are not drawn. So these are the suggestions given. And the corrected diagram also is shown to the students that, how many entity sets you should actually include. What are the relationships actually you should plot? How have you represented the keys? How have you shown the weak entities? So this was the diagram which was discussed. Students note down the diagram, students take the suggestion, and actually particularly this type of exercise is done for all the case studies provided. So in the process, actually, we end up doing more examples, more case studies involving this type of game-based activities. Once all the diagrams were discussed, the leaderboard was prepared. This is actually of the actual leaderboard on our board and the presentable version rather. So we had divided the marking scheme. For functional requirements, entity sets, attributes, relationship sets, domain value, cardinalities, and the marks were provided based on all the attributes or all the parameters identified. And the students were, of course, people who scored good marks were highly motivated. People who scored less at least learned that, what are the errors I am doing. Once this was identified, this activity was done. Now this activity has to follow to the database design. So the entities which were identified here were to be converted to the schema. So the next activity they were provided was that the diagram is to be converted to relational schema. Part of that activity, again, we had briefed them about the abstraction processes, GenSpec structures, aggregation, and once done, they were asked to convert it to the schema, and there, whether for each higher level entity set schema was designed, how were the lower level entity sets and attributes identified, were the keys identified, were the relationships plotted, were the constraints provided, and then finally again marking of the second activity was done. So in the process, we usually observe that once they have solved both the activities, they understand that this type of activity is a progressive type of activity. And I am, or as a student, I learn that, how do I identify entities? How do I identify sets? And once they are taken to activity 3, actually after this activity, the next process is, of course, of normalization, but then we take normalization altogether separately, entirely in detail, because we need to explain the stages of normalization. We need to explain entire normalization process. So here we pause the activity, we ask them to design the relational structure, and we pause this activity by the time we take the next explanations in the class about explaining the normalization process. So once the design was derived, of course, students are in the stage to understand that how actually in-depth explanation of the data models and the ER model helps them in conversion of, or rather getting the optimized database design. And we usually observe that by doing this activity or by implementing the case studies through games, it increases or maybe inculcates more interest towards a particular topic, and especially the students who are introvert or does not speak or does not ask doubts to the teacher, they learn more in this process. So yes, we achieved the good database design, but which has, of course, yet to pass through the normalization process. And following other references we used, our main reference book is Sudarshan Kaur's book in our syllabus. So we use Sudarshan Kaur's book for explaining all the database concepts, some of the gamification research papers, and one of my own research paper for the references used. Thank you so much.